So next sections we shall go what is harmonic functions. So this is a very important topic. So in this topic we have one compulsory 8 mark questions present in the examinations. So topic must be like a easiest one. So first we shall go through the definitions of harmonic functions. So what is harmonic functions? These were two mark questions. A functions u of x comma y is said to be harmonic or real, then the condition is dou square u by dou x square plus dou square u by dou y square equal to 0. That means the simplest form is, so del square of u equal to u double x plus u double y equal to 0. So this is nothing but the partial differential equations with respect to x twicely. Similarly, these are partial differential equations with respect to y. We have to differentiate twice at the time. So this is nothing but harmonic functions. Or simply we have to write a functions u of x comma y is said to be harmonic if dou square u by dou x square plus dou square u by dou y square equal to 0. So these are definitions for the harmonic functions. So we have to prove that LHS equal to RHS. So what is harmonic conjugate? If u and v are the real and imaginary parts of analytic function, then we say u and v are harmonic conjugate. That means, suppose in your problem u is given means, so you have to find the conjugate of u is v. Suppose v is given means you have to find the conjugate of v is u. So we have to interchange it. U is given means we have to find v value, that is a conjugate. V is given means we have to find the u, that is our conjugate of v. So for that case we have the two formula here. So suppose if u and v are harmonic conjugate, then first one is du equal to dou u by dou x into dx plus dou u by dou y into dy. Then integrating on both sides. So integration of du is u, then integration of dou u by dou x into dx plus dou u by dou y into dy. Next one is dv equal to dou v by dou x into dx plus dou v by dou y into dy. That means v equal to integration of dou v by dou x into dx plus dou v by dou y into dy. This formula is nothing but the total derivative formulas. Using that we have to derive the conjugate of u and the conjugate of v. So first we shall go to the problem number 1. So these are very important 13 mark questions. Show that the function u equal to 1 by 2 log of x square plus y square is harmonic and find its conjugate harmonic. So this is a very important one. So first question is, show that the function u equal to 1 by 2 log of x square plus y square is harmonic. So harmonic means, so you have to find u double x plus u double y equal to 0. So LHS equal to RHS. So next we have to find the conjugate. So here is u is given. So we have to find the conjugate is v. So already I gave the formula for conjugate of v here. What is conjugate of v? So that is dv equal to dou v by dou x into dx plus dou u by dou y into dy. So this is a conjugate of v here. So let u equal to 1 by 2 log of x square plus y square is given. So first we have to differentiate with respect to x. So dou u by dou x. So 1 by 2 is constant term, we can keep it as it is 1 by 2. Differentiation of log of x square plus y square. So we know that what is log x? That is 1 by x. The same thing you have to apply here. So we can take this x square plus y square in terms of x only. What is log x? 1 by x. Therefore 1 divided by, so x in terms of x square plus y square. So with respect to x means we have to differentiate this x square. So we get 2x. Then y square must be 0. So therefore cancelling 2 and 2 here. So we get x divided by x square plus y square. So next again we have to differentiate dou square u by dou x square. So we can take these functions. This is a u by v form. So here is I can take as it is. So what is u here? This is a v. V is nothing but v square, that is your formula. x square plus y square whole square. Then v x square plus y square. Then differentiation of x is 1, that is we can keep as it is. Then differentiation of x square plus y square in terms of x means we get 2x. So we get 2x into x is x square. And simplifying this one, we get y square minus x square all divided by x square plus y square and whole square. So this is a u by v form we have to derive here. So u by v is form is already gave in the previous lectures. That is u by v equal to, so v du minus u dv all divided by v square. That is your formula. So you can apply this formula, we get this value. So next with respect to y, dou u by dou y equal to, so we can take 1 by 2 as it is. Then differentiation of log y is 1 by y, so 1 divided by x square plus y square. Again differentiation with respect to y means we get 2y. Then cancelling this 2, so we get y divided by x square plus y square. So again we have to differentiate with respect to x means, so we get, so this is a v square, x square plus y square whole square. Then v x square plus y square minus, then you can keep to y as that, we can keep to y as it is. Then differentiations with respect to y square is we get 2y, so we get y into y is y square. So therefore x square minus y square whole divided by x square plus y square whole square, that is equal to, here is we can take 1 minus outside, so we get y square minus x square whole divided by x square plus y square whole square. Then we can adding the two equations. So one is dou square u by dou x square, then dou square u by dou y square. So we get, cancelling these two terms, we get answer is 0. Therefore u is harmonic. So first part is over. So next, to find the second part, to find the conjugate of u. The conjugate of u is, your formula is v equal to integration of dou u by dou y into dx plus dou u by dou y into dy. So this is a formula given in the previous slide. So first find 1 by 1 here. So dv equal to dou v by dou x into dx plus dou v by dou y into dy. So here is we have to find only u is given. So replace the formula by using CR equations. Dou v by dou x is nothing but minus dou u by dou y. Then dou v by dou y is nothing but dou u by dou x by based on the CR equations. So therefore, so I replace the value dou u by dou x. This one is already we know. What is dou u by dou x? X divided by x square plus y square. So we can replace here. So dou u by dou x is x divided by x square plus y square. Next dou u by dou y. So dou u by dou y is y divided by x square plus y square. So here is we can replace. So here is we have one minus formula minus. So minus y divided by x square plus y square. Then combining these two, denominator must be equal. Therefore, first I can take the positive value x dy minus y dx whole divided by x square plus y square, that is equal to, so here is I can take one x square outside here. So x square means we get 1 plus y by x whole square. Here is we get x dy minus y dx. So this is nothing but u by v formula. So d divided by d of y by x, that is d of y by x whole divided by 1 plus y by x whole square. So this x must be cancelled here. How means, so d by yx is nothing but this is a u by v form. So here is we get 1x square. Then here is also we get 1x square. So cancelling these two, so we get these results. So this one is nothing but integration of dx whole divided by 1 plus x square. That is a formula is tan inverse of x. Here is x is nothing but y by x. Therefore v equal to tan inverse of y by x. So plus c. So this is a very important problem. So this is a very important problem they are asking in the university examinations. So prepare well here. So formula is very important one. So go through the formulas. So don't do any mistake in that formulas. Okay. So next we shall go through the second problem. So prove that u equal to x square minus y square, v equal to minus y divided by x square minus y square are harmonic, but u plus iv is not harmonic, that is regular functions. Okay. So this is a proof here. So first we can find u, then v. Both case we have to find. So first we can find ux. So dou u by dou x is differentiation of x square is 2x, y square must be 0. Then again you have to differentiate this one. Dou square u by dou x square is 2. then dou u by dou y is x square is 0. So differentiation of y square is minus 2y. Then again you have to differentiate this one, we get minus 2. So adding these two, so dou square u by dou x square plus dou square u by dou y square equal to 2 minus 2 is 0. Therefore u is harmonic. Similarly we can take v here. So v equal to minus y divided by x square plus y square. So first we can with respect to x. So differentiation with respect to x means by using u by v formulas. So v square x square plus y square whole square, then v x square plus y square. Differentiation of y with respect to x means 0 minus y into, so differentiation of this value 2x must, differentiation of x square is 2x, then y square must be 0. Then simplifying this one we get 2xy whole divided by x square plus y square whole square. Then again with respect to y, dou v by dou y is, so same u by v formulas, x square plus y square whole square, then x square plus y square, differentiation of x must be, that is y must be 1, then minus, we can keep y as it is, differentiation of y square is 2y, and simplifying this one we get y square minus x square whole divided by x square plus y square whole square. Then second derivative, dou square u by dou x square. So already I told in the previous problem how to find the u by v. So same procedures here is we can apply u by v form. So we get one solutions here. If you have any doubt means we can ask in the group here. Then adding these two things, so dou square v by dou x square plus dou square v by dou y square equal to, adding these two values the answer must be 0. So therefore u is harmonic, then v is also harmonic functions. So next the problem is given, check that this one is not a regular functions. So not regular means CR equation is not satisfied. So dou u by dou x is equal to 2y, then dou u by dou y equal to minus 2y. So dou v by dou x we get one value, 2xy divided by x square plus y square whole square. Then dou v by dou y equal to y square minus x square whole divided by x square plus y square whole square. Then check this one is, so ux divided by uy, so both are not equal to, here is both are not equal to, therefore CR equation is not satisfied, therefore the given function is not harmonic. That means first one is these two are harmonic, therefore the CR equation is not satisfied, so that one is not analytic, it is not regular functions. So we will continue in the next sections. If you have any doubt means we can ask in the group here. Thank you.